Okay, so yesterday we did 3.3, and hopefully you have had chance to take a look at yesterday's lecture. And remember, if you cannot understand some or many of the contents from yesterday's lecture, you will have to watch the video multiple times. And if you still can't figure out something, then you will have to let me know, okay? Because the 3.3 is not simple. So 3.4 is today's topic, and hopefully we go more than 3.4. So here we'll do graphings, graphings of polynomial functions. Okay, so we cannot do the graphings using the calculator, which is I guess the standard way. So we have to have lots of ingredients, okay, in order to get the graph by hand. Okay, so let's start with the first set of ingredients. Okay, so here is the first fact. So suppose f of x has degree n. Okay, so now yesterday I have defined briefly what the degree means. So remember, the degree is the largest exponent. Okay, that's what degree means. So f of x has the largest exponent equal to n, which is some number. Then f of x has at most n x-intercepts. Okay, so f of x has at most n x-intercepts. And remember, the x-intercept is same thing as the word zeros. Okay, so it has at most n zeros. Okay, and now the word at most. So at most means what? The largest possible value is n, right? Okay, so it is the uppermost value. So what does that mean? It's less than or equal to n, right? Okay, so it doesn't have to be just equal to n. It can be less than n, okay? X-intercept. Okay, and now, moreover, it has at most n-1 total peaks and valleys. Okay, so peaks and valleys. So that's kind of an informal way of saying the things so-called maximum and minimum. Okay, but so basically, what does peak mean? So whenever you have a graph like this, okay, so that's the peak, right? Okay, and that's the valley. So what does that mean? That is the peak that is the maximum, and that is the minimum. Okay, so basically peak means maximum and valley means the minimum. And if you look at this graph closely, these peaks and valleys are exactly the turning points. Okay, do you see that? Because the graph is increasing, and then it changes direction, and then it starts decreasing, right? And then it changes direction once again, and it goes back to increasing once again. Okay, so basically peaks and valleys are same thing as the turning points. Okay, so if f of x has degree n, then first it has at most n x-intercepts, which is zeros, and then it has at most n-1 total turning points. Okay, so the number of the turning points is degree -1. Okay, so that is the first fact, which is not that significant actually in terms of the graphing that we are trying to get. The next two facts are important. Okay, so here is the second fact. So yesterday we have looked at the multiplicity, okay, which is what? We have to look at the exponent when f of x is in a factored form, right? Now, suppose such multiplicity is even. So what does that mean? Like 2, 4, 6, 8, and so on. If that's the case, then the graph touches the 0. Okay? And then the graph bounces back. Okay, so in other words, the graph never crosses past the x-intercept or the x-axis. Okay, so even multiplicity means the graph touches and then it bounces back. Now, what if the multiplicity is odd? So that means we have 1, 3, 5, 7, and so on. And if that's the multiplicity of a 0, the graph will cross. Okay. So basically, even multiplicity means the graph touches the 0. If it's odd, then the graph crosses. And this is the first ingredient that we need to have in order to get the graphings or the graphs by hand. Okay, now, first of all, remember from yesterday's class, to find zeros, you may first have to vector f of x. Okay, so remember, without factoring f of x in prior, you cannot conclude what the multiplicity is. Okay, so that's why in order to find zeros and their multiplicities, you first have to factor f of x. Okay, so let's do this first problem here. For the graph below, is this the graph of a cubic function? And what's the reason? Okay, so now the word cubic. So cubic means what? The degree or the largest exponent is equal to 3, right? Okay, that's what the word cube means. Okay, so now, because of the fact number 1, what has to be true for any degree 3 or cubic functions? It will have at most or up to 3 x-intercepts, and it has up to 3 minus 1 or 2 total peaks and valleys. Okay, so because of the above fact, it has at most 3 x-intercepts. Okay, and then it has at most 3 minus 1 or 2 total peaks and valleys. Okay, so that must be true for any degree 3 functions. Okay, so now let's see, okay, whether these are the case for the given graph. So does the graph have 3 x-intercepts? Yes, right, 1, 2, and 3. Okay, so this one is good. Okay, now, does it have at most 2 total peaks and valleys? Okay, so let's see. So where is the peak? Here's the peak, right? Okay, and where are the valleys? These are the valleys, right? Okay, so what does that mean? It has total 3 peaks and valleys. So this condition fails, right? Okay, so what's the answer? Okay. So even if one condition is satisfied, you still have to have another condition satisfied in order to conclude that something is a cubic function or some other degree functions. But if only one condition satisfied, then it's not the case. Okay, you need to have both conditions satisfied. Okay, so that's problem number 1, which was pretty simple. Now, so the first ingredient, remember, to get the graph was the even and odd multiplicities. Now, here's the second ingredient, which actually comes in the next page. But in order to have such ingredient, we need to have ingredient of the ingredient. Okay, so here's the first definition. For a function f of x, the end behavior. Okay, so its name is kind of straightforward. Okay, end behavior. So basically, how the graph behaves at the end, basically. Okay, you can take an easy guess, but the precise meaning is that the end behavior means how the y values, i.e. the graph, behaves at the left and the right ends of the x-axis. Okay, so that's what the end behavior means. And the end behavior is actually pretty simple. There are only two kinds. Go up or go down. Go up or go down like this. Okay, now some people ask, well, what about this horizontal line case? Well, yeah, that's also possible, but that's kind of the stupid case. So we don't consider this horizontal line. Okay, so only going up or down. Okay, so those two are the only end behaviors. Now, why do we ever need this end behavior? Because the second ingredient of the graphing deals with this end behavior. Okay, and here is the second ingredient, the leading term test. Okay, so now the leading term test. And remember yesterday we saw leading coefficient. Okay, so hopefully you can take a guess that leading term and the leading coefficient are somewhat related. And actually they are related with each other. Okay, so the leading term, okay, the word leading term has two parts. The leading coefficient. Okay, so remember from yesterday's class, we defined what the leading coefficient is, right? So what was the leading coefficient? So the leading coefficient is not necessarily the first coefficient, right, that we see. It's rather the coefficient of the term that has the largest power. Okay. And now the leading term also has the degree. Okay, so it has to have both. Okay, and that's why the condition says f of x has the leading coefficient a and the degree equal to n. Okay, because these two are the components of the leading term. Okay, then the end behavior goes like this. So here, the leading term test has this table or the chart. Okay, that looks like this. Okay, so now the leading term, or I'm sorry, the leading coefficient. So remember, any number in front of x or x plus some power can be positive or negative, right? Okay, so we have positive leading coefficient and negative leading coefficient. Now, what about the degree? So, for example, for a polynomial, can you have like negative exponent that goes like this? And the answer is no, right? Okay, so the degree has to be positive, and any positive number can be classified into two categories. And what are they? Even and odd. Okay, so degree cannot be negative. Okay, so only the coefficient can be positive or negative, but the degree is always positive, so it has to be even or odd. Okay, and now we have to fill in the blank. So even degree and the positive leading coefficient, the end behavior is this. Okay, in other words, up, up. Now, what does this up, up mean? Okay, so this arrow means the left end goes up, okay, which is this arrow, and the right end goes up as well. okay, goes up. That's what this means. Okay, and now, if the degree is odd, and still we have the positive leading coefficient, we have this, down, up. Okay, and I'm not gonna write down what this end behavior means, but you can guess what this means, right? So the left end goes down and the right end goes up. Okay, and now, negative leading coefficient. So what do you expect to happen? All of the arrows will be flipped. Okay, so what does that mean? If the degree is even, we'll have down, down. And for the odd degree, we'll have down or up, down. Okay. So now, that is the NBA or the leading term test. But the thing is, people usually have big trouble on memorizing these precise arrows. Okay. So if you feel like memorizing these 4 cases is too much because of like all different arrows pointing in different directions, then my recommendation is come up with the specific functions in each case. Okay, so for example, even degree and the positive leading coefficient. So what is the specific and the most basic function here? X squared. Okay, in other words, y equals x squared. And we know how its graph looks like, right? Okay, so its graph looks like how? This one, right? And now, how does the ends, or how do the both ends behave here? They are going both up, right? Okay. And now, the odd degree and the positive leading coefficient. So here, my recommendation is look at y equals x, which is the degree 1, right? But sometimes people look at x cubed. Okay, it doesn't matter. Now, y equals x, it's a line, right? It's an increasing line. So how does the left end behave? It's going down. The right end is going up. And for the x cubed, the graph looks like this, right? No, looks like this. So the left hand is indeed going down, right hand is indeed going up, right? Okay. And then negative leading coefficient. So we can look at negative x squared. Okay, so now how does the graph look like? It is the upside down parabola, right? And the end behaviors are what? Both ends are going down, right? Okay, and for this case, we can look at negative x or negative x cubed, either way. So now, y equals negative x, it looks like this, right? Okay, and the left hand is going up, right hand is going down. And for the negative x cubed, it's the other way, s, like that. So indeed, left hand going up, right hand going down. Okay, so again, you can memorize these 4 arrows, but if that is confusing, then my recommendation is come up with x squared, x, negative x squared, and negative x, and you know how their graphs look like, so you know the end behaviors right away. Okay, and that's what I said here. Okay, so now let's do this problem. Find the end behavior of the following polynomials. So part A, f of x is equal to 5 plus 3x squared plus x cubed minus x. Okay, so now remember, to get the end behavior, we need to apply the leading term test. And to apply the leading term test, we need what? Leading coefficient and the degree, right? Okay, so we need to find the 2 things. Now, which one is easier to find? It's easier to find the degree first, okay? Because the degree means what? The largest exponent, right? Okay, So here, what is the largest exponent? 3, right? Okay, and now, what is the leading coefficient? The leading coefficient is not 5, right? Okay, remember the leading coefficient may not be the first number that you see. Okay, so the leading coefficient has to belong the degree term, right? So the leading coefficient is what? 1, right? Okay. So now the degree is 3, which is an odd number, and the leading coefficient is positive. Okay, so think about the specific function here. So odd degree and positive leading coefficient. So what's an example? Like y equals x or x cubed, right? Okay, whose graph is what? Like this, it's an increasing line. So how does the end behavior look like? The left hand going down, right hand going up. So what does that mean? It's this one. Okay, so typically what people ask is, how should we answer the question of end behavior in our homework? And the thing is, I honestly cannot remember because I don't have to do your homework. But either you will see like these arrows, like down, up, down, down, things like that, or you will see some kind of phrase that looks like the left end decreases, the right end increases, or the left hand decreases and the right hand decreases, and things like that. Okay, so just for simplicity, I'm adopting these two arrows or arrow representations, but you may not see these arrows in your homework, but you'll see the similar or the equivalent expressions instead. Okay, so now that was A, and then B. X to the 4th minus x to the 5th minus 3x squared plus 2. Okay, so again, we have to find the degree and the leading coefficient. So here, what is the degree? So the degree is the largest power, so it has to be 5, right? And what's the leading coefficient? So the leading coefficient belongs to the degree term, and its coefficient is -1, right? Okay, so the degree is once again odd, and the leading coefficient is this time negative, right? Okay, so it's the odd degree and the negative leading coefficient. So a sample function is -x or -x cubed, either way, whose graph is what? This one, right? It's a decreasing line. And according to this graph, it says the left hand is going up, right hand is going down. So what is the end behavior? Down or up, down, right? Okay. So that is B. And now, part C. Okay, so now part C. So this problem can be tricky. And hopefully you can see why. So here we have -2 times x squared minus 2 times x minus 1 to the 4th power. Okay, now here we need to find the degree and the leading coefficient. Now here, what is the degree? So people say the degree is 4 because that is the largest exponent available, like it's greater than 2 for sure, the other exponent. Okay, but is 4 really the degree? Okay, so what is the difference between this and the previous two problems? Okay, so these are just completely foiled version, right? Okay, whereas this one, it's not foiled. Okay. So here, what do we do then? Do we FOIL? Well, you don't have to. Okay, people sometimes try to FOIL and then most of them are not successful at all. And then they're kind of confused by themselves. So instead of FOILing, we will just do F. Okay, so in other words, we will do F from FOIL. Now, what does F mean? It's not the prohibited F word, right? F from FOIL means what? The first term, right? Okay, so it's the first term. Okay, first term. Okay, so now, let's say you want to FOIL this. Okay, now, again, I didn't say we are gonna FOIL, but suppose you are FOILing this. Then what do you do first? You will do this one first, right? Okay, because that's the exponent, the real exponent part, right? Okay, so now, again, remember, we are only looking at the first term. So, FOIL x minus 4 to the fourth. Okay, then what is the first term? So, it's x minus 1 multiplied 4 times, right? So what will be the first term? X to the fourth, right? Okay, and then we have something, right? Which we don't care. Okay, so we have f of x, which is equal to -2 times x squared minus 2 times x to the fourth plus whatever, which we don't know. Okay, and then what do you do next? That, right? Okay, so again, imagine you are FOILing this. Then what do? You do this one, right? And then so on and so forth. But again, we don't care what's going to happen after the first term. And what is the first term here? X to the sixth power, right? Okay, and then plus whatever, which we don't care. Okay, and then what is the final task? You will distribute to -2, right? Okay, so what is the first term of f of x? The first term of f of x is now what? -2 x to the sixth power, right? Okay, and then something will happen in the back, which we don't know. Okay, but we don't need to know, right? Okay, so that is the first term. And this first term contains all the ingredients that we need, right? Why? Because here, what is the degree of this function? 6. Okay, and every other exponent will be smaller, right? And what is the leading coefficient? -2. Okay. So the degree is this time what? Even, right? And then the leading coefficient is negative. Okay, so the even degree and the negative leading coefficient. So what is the sample function? -x squared, whose graph is what? Upside down parabola. So what's going on at the two ends? They are going down, right? So the end variable is down, down. Okay. Okay, so basically when your function is not FOILed completely, then you have to kind of FOIL, but you don't have to completely FOIL, just look at the first term, okay? But if it's already FOILed for you, then you don't have to do anything else, just look at the degree and the leading coefficient. Okay, so apparently, just like yesterday, all of you are in the muted mode, so I cannot really say anything. But remember, if you have any questions, just feel free to stop me, okay? Because if none of you stops me, then I have to assume that it's okay for me to go on, okay? So, any questions? Nope? Okay. Yeah, so maybe I should just like turn off my video or something, because like all I see is just like dark screens, like, and it kind of like feels like, yeah, it's a gloomy day for sure, like for 2 days in a row, but you don't have to be just like completely dark. I don't know, like I might be like dark dungeon or something. Anyways, so scheme to graph a polynomial. Okay, so now we have nearly all ingredients. Okay, so now let's try to look at how to graph a polynomial by hand. Okay, so first, find the zeros. Okay, so find x-intercepts or zeros. And how do you find them? Remember, you might have to factor f of x completely. Okay, because if you don't, it's tough to find what the zeros are, and it's tough to find what are their multiplicities. Okay, and then step number 2, find the y-intercept as well. And remember, how do you find y-intercept? Set x to 0, right? Okay, and step number 3, use the end behavior. Okay, and then the even and odd multiplicities as well. Okay, so basically we are combining what we have learned so far. Okay, so we find the y-intercept, okay, and then we look at the end behavior, and then we look at the even and odd multiplicities. Okay, and let me tell you, so for graphing polynomials, so let's see, when you graph a line, you needed 2 points. When you graph a parabola, you needed 3 points. Okay, and remember, parabola means quadratic function whose degree is equal to 2. So maybe you can take a guess. How many points are we going to need for graphing a cubic function, degree 3? You need 4. Okay, so that's 1 point. And then the x-intercepts, well, maybe there are 2 or 3 x-intercepts. Okay, so just in case the total number of y-intercept and x-intercepts are not equal to 4, then you may have to find yet another point. Okay, so you need 4 plus points. Okay, to graph, that's not 4t, 4 plus points to graph any higher degree polynomials. Okay, so you need at least 4, basically. Okay, so let's keep that in mind. So now, here's part A, graph each. Okay, so x plus 2 to the 3rd power times x minus 1 squared. Okay, so now, do you have to follow this? And the answer is, please don't. Okay, and guess what you have to do if you FOIL? Come back to this step. Okay, so no FOIL here. That's not the point. So now, step number 1. Let's first find the zeros or x-intercepts. Now, since f of x is already factored, we don't have to factor f of x any further because it's been done for us. Okay, so find the zeros. Okay, now remember, zeros is the same thing as the x-intercept. So how do you find the x-intercept? Set y equal to 0. So what does that mean? Set this whole thing equal to 0, right? Okay, so what does that mean? X plus 2 is equal to 0, and x minus 1 is equal to 0, right? Okay, so What are the zeros? -2 and 1, okay? But we need the x-intercept, okay? So what are the x-intercepts? -2, 0, and 1, 0, right? Okay, so these are the x-intercepts. Now, again, I'm not saying those are the notations for the zeros, okay? These are the x-intercepts, okay? And the zeros are -2 and 1, okay? Even though they mean the same, the representation is not the same, okay? And now, let's find the multiplicities. Okay, so now, what is the multiplicity of 1, 0, which is -2? The multiplicity, remember, we have to look at what? The exponent, right? Okay, so the multiplicity of -2. So -2 came from x plus 2, whose exponent is 3, right? Okay, so its multiplicity is equal to 3. Okay, so now remember from the previous fact, which was on the first page, if the multiplicity is odd, the graph crosses the 0. So the graph will cross -2. Oops. -2, 0. Okay, now be careful, it doesn't cross out, or it does not cross 3, right? Because 3 is just the multiplicity, not the actual 0. Okay. And now another 0, or the other 0, which is 1. What is its multiplicity? It's 2, right? Okay, so its multiplicity is 2, and remember, if the multiplicity is even, the graph will touch the corresponding 0 and then it bounces back. So the graph will touch 1, 0. Okay, and now the next thing, find the y-intercept. Okay, so this time we set x equals 0. So what's the value of y? So here, when you plug in 0, what do you get? 2 cubed times -1 squared, right? Okay, and what is this? 8 times 1, so that's equal to 8, right? So the y-intercept is at 0, 8. Okay, so that's the y-intercept. And then the end behavior. Okay, now we just did problems about the end behavior, right? Okay, so remember, to find the end behavior, what do we need? The degree and the leading coefficient, right? Okay, so now what is the small issue here? F of x is in a factored form, so it's kind of similar to the one or the problem before, right? Something like this. Okay, so here, please do not say the degree is equal to 3. Okay, that's not the case, right? Because this one is in a factored form. So what do you have to do? Find, oops, the first term, right? We need the first term. Okay, so how do we find the first term? So if you were foiling this, what do? You do this one first, and then that one next, and then foil this all together at the end, right? Okay, so now, what is the first term of x plus 2 cubed? X cubed, right? Okay, and then it goes on and on, but we don't need to care, right? And then we have x minus 1 squared. Well, we know x squared is the first term, but again, we don't care what happens after that. I mean, it's kind of easy to get what happens after that, but we don't look at them, right? And then finally what you are doing is what? You have x cubed and then times x squared plus something, right? Okay, so when you follow, what do you get? That's the first term. X to the 5th power, right? And then plus whatever. Okay, so that is the first term. So what is the degree? It's not 3, it's rather 5, right? And what is the leading coefficient? It's 1, right? So the degree is odd and the leading coefficient is positive. So what is the sample function? Y equals x, whose graph is like this. So what's the end behavior? Down, up, right? Okay, so now one more. Okay, so how many points have we found so far? We have the y-intercept. We have 2 x-intercepts. Okay, so we are missing 1 point, right? Because we need at least 4 points. Okay, so here what can we do? We can just plug in an easy number, 2x. Now, people will try, in most cases, x equals 1. Okay, but what is the small problem if we try x equals 1? When x is equal to 1, we know what's going to happen to the y value. And what's the y value? 0, right? Okay, so we cannot use 1. So we have to use the next easiest number, which is what? Maybe 2, right? Because here negative 2 was used, so we don't need to use that. So we can use 2 maybe, okay? So when x is equal to 2, what's the value of y? Okay, so we have 2 plus 2 cubed, right? So that means 4 cubed. And then times 2 minus 1 squared. So that's just 1 squared, right? Okay, so now 4 cubed. So that's what? 16 times 4, so that's 64, right? Okay, and that's 1. So y is equal to 64. So it passes 2, 64. Which is rather big point, okay? So now, we have all the ingredients, so let's graph. Okay, so here is the xy plane. Okay, now, there are 2 x-intercepts, remember, negative 2, 0, and 1, 0. Okay, so negative 2, 0 is here, and then 1, 0 is right here. And then the y-intercept is at 0, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then it also passes 2, 64. Okay, so apparently this one has to be out of scale. So maybe somewhere here. Oh, okay. So now we know the end behavior, and what was the end behavior? Down, up, right? So what does that mean? Down and then up. Okay, and then the graph has to cross negative 2, 0. So what's the only option? That, right? Okay, and then since it has to pass the y-intercept at 8, what has to happen? So the graph keeps going up, and then it has to pass 0, 8, like this, right? And then the graph has to touch 1, 0, which is this point. So what does that mean? The graph has to change the direction, and then it decreases, and then it touches and bounces back, like this, right? Okay, and then it also passes 2, 64. So what does that mean? The graph has to increase like this, right? Okay, and forget about this like little arrowhead here. Okay, and so that's the graph, right? Okay, so in short, how does the graph look like? It's this, right? Okay, which is the cubic function graph. Okay, so that is A, and now B, and now B. Okay, so 2x to the power 8 minus 2x to the fourth. Okay, so now here, what is the issue? Okay, so here we have to find the zeros, but can we set f of x equals 0 like that right away? And the answer is no. And what is the problem? Your f of x is not factored. Okay, so your f of x is not factored, and you have to factor it first to find the x-intercept or zeros. So we have seen a similar problem like this yesterday, but how do we factor this f of x completely? So here we have to first find the so-called the GCF. And what's the GCF? So 2 is part of the GCF, right? Because that's the common coefficient. And then for x, we can take out x to the what power? The 4, right? Okay. So once you take out 2x to the power 4, what do you have? X to the fourth minus 1, right? Okay. And now, can you factor this x to the fourth minus 1 further? And the answer is, it doesn't look like it's possible, but it is possible. And here's my hint. X to the fourth is x squared squared. And then 1 is 1 squared. Okay, so we have something square minus something square, and that's the difference of squares, remember? So we have 2x to the fourth times x squared minus 1 times x squared plus 1. And now, is that it for the factoring? And the answer is not really. Why not? Because what can be factored further? That. Okay, which is another difference of squares, right? So we have 2x to the fourth times x minus 1, x plus 1. Okay, and now what about this x squared plus 1? Is that equal to x plus 1 entire thing squared? And the answer is no. Why not? Because if you FOIL this, do you get x squared plus 1? Or do you get something else? So when you FOIL this, you get what? X squared plus 2x plus 1, right? Okay, so it's not equal to x squared plus 1, right? Okay, so what does that mean? It's not equal to x plus 1 squared. So what does that mean? You cannot factor. Okay, people try to factor this, and then all of them are not successful because they can't. Okay, so you cannot even factor this. So x squared plus 1 stays the same. Okay, so that is the complete factorization. Okay, and now step number 2 is what? Now we can find the zeros. Okay, so to find the zeros, we set this whole thing equal to 0. Okay, so what does that mean? Do we set 2x to the fourth equal to 0? Yes, we saw a similar problem yesterday, right? Okay, even if something is not within the parentheses, as long as that contains the x, you have to set it equal to 0. Okay, and then x minus 1 is equal to 0. X plus 1 is equal to 0, so that's pretty easy. And then x squared plus 1 is equal to 0 as well. Okay, and now, how do you solve the first equation? You divide by 2, so you get x to the fourth is equal to 0. Okay, now the fourth power may scare you, but you are raising something to the fourth power, but the answer is equal to 0. So what has to be the value of x? The simplest one, right? Okay, and then this means x is equal to 1. That means x is equal to -1. And now what about this? So from here you subtract 1. So we have x squared is equal to -1. And then you take the square root. Okay, so x is equal to square root of -1. Yeah, right? And then if you thought that was it, not really, right? Okay, yeah, don't forget the plus minus whenever you're taking the square root. And now, square root of -1, what is that? That's an I, right? Okay, so we have x is equal to plus minus I. Okay, so now, let me ask this question, which is kind of tricky. What are the zeros here? So what are the zeros? Is the zeros 0, 1, -1, and plus minus I, or is it something else? So basically, you can guess that 0, 1, and -1 are part of the zeros, right? So the real issue here is plus minus I the zeros? Are they zeros? And here's my another hint. Remember, 0 is same thing as x-intercept. So is plus minus I the 0, or are zeros?
No, because they aren't real numbers.
Right? No. Okay, because on the xy plane, there's no place for the imaginary numbers, right? Okay, so that is not a 0. Okay, now I know that in the previous section in yesterday's class, we saw that imaginary number can be a 0, but remember, we are focusing on the graph this time. And for graphings, we are dealing with xy plane, right? Which does not contain any imaginary numbers. So that's why plus minus I is just out. Okay, so what are the x-intercepts? 0, 0, 1, 0, and -1, 0. These are the x-intercepts. Okay, so now let's find the multiplicities. So multiplicity. Okay, so now remember, how do we find the multiplicity? So we have to find the multiplicity of 0, 1, and -1. Okay, the 3 zeros. So let's start with the 0. What is the multiplicity? So to find its multiplicity, we are looking at what? The original f of x? This one? No. We are looking at what? The factored form, right? This one. Okay, and 0 came from where? 2x to the fourth, right? Whose exponent is even, or I'm sorry, whose exponent is 4, right? So its multiplicity is 4. Okay, and since this number is even, the graph will touch 0, 0, right? Okay, the graph touches 0, 0. Okay, and now the second 0, which is 1. So the second 0, 1 came from where? X minus 1, whose exponent is what? Also 1, right? So its multiplicity is 1. Okay, and since this multiplicity is odd, the graph will what? Cross, right? Okay, and then the third 0, negative 1. What is its multiplicity? The negative 1 came from x plus 1, whose exponent is what? Again 1, right? Okay, so its multiplicity is also 1. And the graph will cross once again. Okay, so now the y-intercept. Okay, so what does that mean? Set x to 0, right? Okay, so now going back to the original function, when you set x equals 0, what happens? Both terms are gone, right? So y is equal to what? 0, right? Okay, so the y-intercept is same thing as one of the x-intercepts, 0. Okay, that's kind of unfortunate, right? Now, the next step, the end behavior. Okay, so now remember, to find the end behavior, what do you need? The degree and the leading coefficient, right? Okay, so here, what is the degree? So the thing is, if you look at this factored form, it might be tough to find what the degree is, but hey, that's okay, because we can look at what? The original f of x, right? The given expression. And what's the degree? 8, right? Okay, and what is the leading coefficient? The 2, right? Okay, so the degree is even, and the leading coefficient is positive. Okay, so what is the sample function here? We have to look at y equals x squared, whose graph is this one. Okay, so what's the end behavior? Up, up, right? Okay. Okay, so now here, how many points have we found so far? So we have 3 x-intercepts. Okay, 1, 2, 3. And then we also have the y-intercept, but it's the same thing as one of the x-intercepts, right? Okay, so we technically have 3 points. And remember, that's not enough. Okay, so we have to plug in a number to x. Now, another issue here is what? We can try with 1, but 1 has already been used, right? And same thing for negative 1. So what's the only option? Unfortunately, 2, I guess. Okay, so another point. So try to plug in x is equal to 2. Okay, so now try plugging in 2 into this factored form. Okay, so what do you have? 2 times 2 to the 4th, right? Now 2 to the 4th is 16 times 2, so that's what? 32, right? Okay, so we have y equals 32 times 2 minus 1, so that's 1, so that's meaningless. And then 2 plus 1, so that means 3, right? Okay, and then 2 squared plus 1, so that's 4 plus 1, so that's 5, right? Okay, so we have 32 times 3 times 5. Okay, so what is this? 96 and then times 5. Okay, so that's kind of big number. Like maybe 480-ish. Okay, so anyways, so we got extremely big number. Okay, but it is what it is, right? So we have 2,480. I think the problems in your homework might deal with a lot smaller number, but hey, in class I can do extremely difficult problems, right? Yeah. So now we have all the ingredients. So let's graph. So here's XY plane. Okay. Now there are 3 x-intercepts, -1, 0, and 1. Okay. And now the graph crosses -1 and 1, and it touches 0. Okay. So what does that mean? Since the graph has up as the end behavior, so it kind of looks like this, and then it crosses -1. Okay, and now the graph has to touch 0, so what has to be the case? The graph has to change the direction, and then it touches 0, and then it bounces back, right? So the graph still stays below the x-axis. Okay, and then the graph has to cross 1. So what's the only option? The graph has to change the direction, and then it goes like this, right? And then the graph has to keep increasing, right? So there's 2,480, like way up there. Okay, not in scale, but that's the rough graph, right? Okay, so the W shape is the rough graph for this case. Okay, any questions on these graphing problems? Now, yeah, this graphing is hard, but the thing is, it looks hard because we need so many ingredients. Okay, and once we have lots of ingredients, then it's kind of less scary to get the graph. Now, the last problem of the section is this. -x to the 4th minus 2x cubed plus 8x squared is our f of x. Answer the followings. Part A, factor f of x completely. Okay, so what does that mean? We first have to take out the GCF, right? Okay, and now what is the GCF here? So there is x squared in common, but you can take out one more, which is what? The negative sign, right? Okay, so you have what? -x squared times x squared plus 2x, right? And then minus 8, right? Okay, and now, is that it? No, you can factor x squared plus 2x minus 8 further, right? So what do you get? -x squared times x minus 2 times x plus 4, right? Okay, and then we are done. So that's the complete factorization. Now, find the zeros and their multiplicities. So how do you find the zeros? Set this whole thing equal to 0. Okay, so what does that mean? -x squared is equal to 0, x minus 2 is equal to 0, and x plus 4 is equal to 0, right? Okay, so now, from the first equation, -x squared is equal to 0, so you divide by -1, and then you take the square root. So you can see that 0 is a 0, right? Okay, 0 is a 0. The number 0 is the word 0, right? Okay, if you want to be kind of explicit. And then x equals to 2 is another 0, and -4 is another 0, right? Now, be careful. If the problem says find the zeros, then you must stop right here. Okay, It's not 0, comma 0 and 2, comma 0 and negative 4, comma 0. Those are the x-intercepts. Okay, although both mean the same thing, the representation is different. Okay, remember that. These are the zeros. Okay, so 0 is the value, not the ordered pair. And what are their multiplicities? So what's the multiplicity of 0? It's 2, right? The exponent. And what's the multiplicity of 2? 1, right? Because of that. And then the multiplicity of negative 4 is this one. Once again, it's 1, right? Okay, so these are the multiplicities. And now, part C. So this one is kind of tricky. Find the behavior of the graph at each 0. So here's my question. Does this mean the end behavior? No. Okay, so don't be tricked by the word behavior. Okay, so here, if it were the end behavior, it will explicitly say as end behavior, or how does the function behave at the ends or something. Okay, so there has to be the word end or end behavior as a whole, but it just says behavior at each 0. So what does this question even mean? Crosses or touches. Okay, that's what the problem is asking you. Okay, so again, don't be tricked by the word behavior. Okay, behavior does not necessarily mean end behavior. Okay, if it were the end behavior, it will explicitly say it. Okay, so behavior at each 0 means crosses or touches. Okay, and how do we know it? Well, we look at the multiplicities, right? Okay, so how do we know? At 0, 0, okay, at 0, 0, which is one of the x-intercepts, right? The graph will what? Touch, right? Because the multiplicity is even. And then at 1, 0, no, 2, 0, and negative 4, 0, at these two x-intercepts, the graph does what? Crosses, right? Because the multiplicity is odd, right? Okay, so that is the answer. Okay, so now that was C, and then the last problem is D, which is get the graph. Okay, so now we nearly have all the ingredients, right? Except what? We still need the end behavior because we haven't found them. And then we have to find the y-intercept. Okay, so let's first do the end behavior. Okay, now to find the end behavior, remember what do we need? The degree and the leading coefficient, right? And it's easier to look at this original function here. So the degree is what? 4, right? And the leading coefficient is negative 1. Okay, so the degree is 4 and the leading coefficient is negative 1. So the degree is even and the leading coefficient is negative. So what's the sample function? Negative x squared, right? Whose graph is what? Upside down u. So the end behavior is what? Down, down, right? Okay. And then the y-intercept. Okay, so now you plug in x to 0 or 0 to x. So what do you get? 0, 0, 0. So it's again 0, right? Okay, so it's again 0. So it's 0, comma 0. Now, do we have 4 points? Not really, right? Because what were the x-intercepts? 0, 0, 2, 0, and negative 4, 0. So we have 3, but that's same thing as the y-intercept, so we just need one more, right? Now, what's the good news here, though? We haven't used x equals 1, right? So we can just plug in x equals 1, okay? Now, when you plug in x equals 1, what do you get? It's negative 1 to the 4th minus 2 times 1 cubed plus 8 times 1 squared, right? And what is this? Negative 1 minus 2 plus 8, right? Okay. So again, we need another point. Okay, so x is equal to 1. So y is equal to negative 1 minus 2 plus 8. And what is this? Negative 3 plus 8, so that's 5, right? Okay, so another point, we got 1, 5. Oh, that's a whole lot nicer point than 2, 480, right, in the previous problem. Oh, that's a really good news. Okay, so now let's graph. So here is xy plane. Okay, so the x-intercepts 0, 0, and another one was at 2, 0, and then another one was at negative 4, 0, 1, 2, 3, 4. Okay, and then it also passes 1, 5, so 1, 2, 3, 4, 5. So that point, okay, and now the end behavior was what? Down, down, right? So which is what? This, right? Okay. Now, from part C, we concluded that the graph crosses 2 and negative 4. So what's the only option? This and this, right? Okay. Now, remember, the graph crosses 1, 5. So what has to be the case? The graph has to keep increasing, and then it hits 1, 5, right? And then the graph touches 0, 0. So what has to be the case? The graph changes the direction, and then it touches 0, and then it bounces back, right? Okay, something like this, right? And now how do you connect these two portions? Just like somewhere in the middle, the graph changes direction once again, and then what do you have here? Just upside down W, right? Okay, so that is the rough graph. Okay, so any questions on these graphing problems by hand? Now, unfortunately, we will see some more graphing problems, but it's not this bad. Okay, like, yeah, there are some tough ones, but it's not as bad as like these problems. Okay, it's just super tedious. Okay, so now that's the end of 3, 4, and then I will go all the way on to chapter 5. Okay, so for this exam 3, right? Yeah. I think the toughest section is on 3.3 and 3.4. And maybe 2.7 as well, but 2.7 was not too terrible. 5.1 and then 5.5, those two are pretty straightforward, okay? And maybe some of you have already seen these before. Systems of equations in 2 and 3 variables, okay? Now, if you have not seen the systems of equations, here is the brief overview, okay? So, the systems of 2 equations mean we have 2 linear equations in x and y bundled together. Okay, so here's an example. 4x minus 3y equals 14. That's a linear equation, right? Because the graph will be a line. Okay, And then here's another one, x minus 2y equals 1. That's also a line, right? Okay, and these two are bundled together, okay, like here in curly bracket. Now, have you all seen this system before, like this kind of system? It's kind of famous. Now, the solution of a system, okay, is the ordered pair a comma b, okay? So the solution means the point a comma b, such that when you plug in x equals a and y equals b to both equations, and how many equal signs do you have to get? 2. Okay, now what if you got an equality on one of the equations, but not the case on the other equation? That is not a solution. Okay, so you must get 2 equalities, not 1. Okay, so here is an example. For the above system, is 3, 1 a solution? What about 5, 2? So start with 3, 1. Okay, so what does that mean? X is equal to 3 and y is equal to 1, right? Okay, so what do you have to do? Plug in x equals 3 and y equals 1 to both equations, right? Okay, not just one, right? Okay, so what do you get? So let's see, from the top equation, we have 4 times 3 minus 3 times 1 is equal to 14. Okay, and then 3 minus 2 times 1 equals 1, right? Okay, and what is this? 12 minus 2, so that's 10, right? So 10 equals 14. 12 minus 3, so that's 9, right? Oh, I cannot even subtract. There we go. So 9 equals 14. Okay, and 3 minus 2, so that's 1 equals 1, right? So now, what do you notice here? So 9 equals 14. That looks terrible, right? Yeah, it's not even bad, right? It's just worst, right? And 1 equals 1 looks good, right? So is 3, 1 solution? No, right? Because even though we got this equality for the bottom equation, we didn't get an equality at the top equation, so it's not. Okay? And now, what about 5, 2? Yeah, in the past, one person said, oh yeah, that's a solution. And I said, why? Or how do you know it? And he said, well, because that answer was no, so the answer for 5, 2 better be yes. Oh yeah, I was like, impressive. You have an excellent guessing skills. And yeah, that should be the case, right? But let's verify, okay? So here, what do you do? Plug in x equals 5 and y equals to 2 to both equations, okay? So what do you get? 5, so 4 times 5 minus 3 times 2 equals 14. And then 5 minus 2 times 2 equals 1. Okay, so what is this? 20 minus 6, so that's 14, right? And then 5 minus 4, so that's 1. So 14 equals 14 and 1 equals 1. Oh, both look good, right? So what does that mean? Yes, it's the solution. Okay, so that is the first example. Now, how do we solve any systems of equations? Okay, so here we just had to verify whether something is a solution or not, but in general, how do you solve the system? And there are 4 methods. The first one is the graphical method. Second one is called substitution method. Third one is called the elimination method. And the fourth one will be introduced in the next section. And what I mean by the next section is 5.3, which we will do, I think, next week, I think, next Monday. Okay, but until we get there, within this section, I'm gonna focus on graphical substitution and elimination. Okay, now here is the graphical method, which looks awfully short, and there's a reason. So what's the scheme? Draw the graph of both equations, and we know their graphs will be what? Lines, right? Okay, and then find where they meet. Oh, how simple is that? Okay, it's awfully simple, but is this really simple? And the answer is no, because, I mean, you can, yeah, get the 2 lines like that, but guess what? If you don't get the precise graph of both lines, it's very tough to tell where this intersection is. Like if the intersection like this is at -4, 1 or -1, for example, then yeah, oh, that's a good point. But what if it goes like this? -4/17, -1/5. Can you even guess such point? If you can, then I guess you have to be joined by the Mensa, the brilliant, or the group of brilliant people. The mundane person like me cannot find such weird intersection points, okay? So what's the point? That's what the graphical method means, but it's really inefficient. So here's the good news. You don't even have to know this graphical method. Okay? That's what it says, but you don't even have to know it, okay? Now, the substitution method, that's something you have to know, okay? So this one is important. The graphical method is not that important, but the substitution method. And here is the scheme. Choose an equation, either the top one or the bottom one, and then isolate x or y. It doesn't matter. Okay, so isolate x or y by itself. And now, here is my suggestion. Choose an equation where x coefficient or y coefficient is 1 or -1. Okay, now the thing is, this scheme works for any system even when x or y coefficient is not equal to 1 or -1. But to make your lives a little bit simpler, that's my suggestion, okay? And now, step number 2. Substitute the other side of your result from the previous step to the corresponding variable in the other equation, i.e. the equation that you didn't pick in the previous step, okay? Now, apparently, this step number 2 sounds very tough and challenging, but the thing is, it's actually very simple. And why does it look awfully hard? Because I had to translate all the math in English, and that see, you know, like that's a downside. So in math, it's just really simple, as you will see. But yeah, English makes like math like 1,000 times harder. Okay, so this one is not that hard, but it sounds confusing. But that's because I have to translate all the scheme in English. But anyways, okay, trust me, it's not that hard. And now, step number 4. Solve for the corresponding variable. Okay, so solve for the variable. Okay, so here it means x or y, whichever is left over, you know, after step number 2. And then remember, that's not it, because Here it says the variable, so what does that mean? Just one of them, right? Okay, but that's not enough. Why? Because our answer has to be in the ordered pair form x comma y. So what do you have to do? Once you find the value for one of the variables, plug in the value in either equation, okay, and find the value of the remaining variable. Okay, now here I said or either equation, which means it doesn't matter which equation you choose to plug in the value, but there will be an easier equation to work with. Okay, so there will be an easier equation for sure, and you can see which one is the easier equation. So maybe the coefficient is smaller. Okay, so that's one option, and then like one of the variables might be isolated already. Okay, so just look at the two equations and then choose whichever feels easier for you. Okay, so now let's do a few problems. So solve by the substitution method. 2x plus 7y equals negative 12 and x equals 3 minus 2y. Okay, now what I typically do is I typically label each equation as A and B, okay, instead of denoting as top and bottom. Okay, now substitution method says what? Step number 1, isolate x or y, right, in one of the equations. Now, on this number 1, how do you isolate x or y from which equation?
You could solve for y on the bottom equation by subtracting 3 and dividing by -2.
Okay, so now for the bottom, do you have to isolate y, or is something already isolated?
X is already isolated.
X is already isolated, right? Yes, okay. And remember, you don't have to isolate y, right? It's just x or y, whichever is easier, okay? And the convenient thing about the bottom equation is x is already isolated, okay? So x is already isolated in B, okay? So step 1 is already satisfied right away, okay? And now, what is the step number 2? So that tricky thing, right? Substitute the other side of result from 1 and plug that into the corresponding variable in the other equation. Okay, so now what do I mean by that? So what's the other side of B? 3 minus 2y, right? And plug that into where? The corresponding variable x in which equation? The top equation A. Okay, so in other words, plug in 3 minus 2y into x in A. Okay, we substitute x or 3 minus 2y instead of x in A. How simple is that? See, I had to translate all the math in English, so that's why it caused trouble in that step number 2. But hey, that's what it is. Okay, so what do you get? 2 stays the same at the top, right? Okay, and then instead of x, what do you have? Times 3 minus 2y, right? Okay, and then plus 7y equals negative 12. Okay, and now, do you know how to solve this equation? Oh yeah, it's just simple linear equation, right? So what do? Distribute 2. So 6 minus 4y plus 7y equals negative 12. And what is this? 6 plus 3y equals negative 12, right? Okay, and then you subtract 6, right? So you get what, negative 3y, oh no, positive 3y equals what, negative 18, right? Okay, and then you divide by 3. So y is equal to what? Negative 6, right? Okay? And now, are we done? No, right? Remember, we have to have our answer in ordered pair, but we only got one of the values. And now, what do you have to do? Plug in y equals negative 6 to either equation, right? Now, is there an easier equation to work with? What is the easier equation, A or B?
B.
The B, right? Yeah, do you see that? Because here, not only the numbers are smaller, but x is already isolated, right? Yes. Okay. So x is equal to 3 minus 2 times negative 6. And what is this? 3 plus 12, right? Which is equal to 15. Okay. So how should we write our answer? The answer is ordered pair 15 comma negative 6. Okay, that's negative. Okay, you must write your answer like this. The common mistake that people make on the homework and the exams is 15 comma negative 6. And what is missing? Parentheses, right? And then they lose everything. Woo! Okay, so how sad is that? So you need parentheses, okay? And then you need 15 comma negative 6 inside. Okay, yeah. Now, that is A, and then B. X plus 4y equals negative 1. And 2x minus 5y is 11. Okay, so again, let me label A and B as top and bottom equations. Now, here, what's the issue? Neither equation has x or y being isolated, right? Okay, so are we in trouble? Not really. So now, choose which equation and isolate what variable?
A and isolate X.
Okay, and do you see why? Because what was my suggestion? Because choose an equation whose x or y coefficient is 1 or negative 1, right? So do we have any case like that in A or B? Yes, A, right? So in A, x coefficient is 1. So isolate x in A. So how do you isolate x? You subtract 4y, right? Okay, so minus 4y. So what do you get? X equals negative 1 minus 4y, right? Okay, so now what do you do? Now you substitute, right? Okay, so now how do you substitute? So you plug in what? Negative 1 minus 4y into where? X, right? In which equation? The equation that you didn't use in the previous step, which is what? B, right? Okay. So plug in negative 1 minus 4y into x in B. Okay. So that goes into here. So what do you get? 2 stays the same. And then times negative 1 minus 4y. And then minus 5y in the back equals 11, right? Okay, which is kind of simple equation, and we can solve it. So what do you get? Negative 2 minus 8y minus 5y equals 11, right? Okay, and combine like terms. So negative 2 minus 13y equals 11. Okay, and then by adding 2 to each side, So negative 13y is just 13, right? And so what's the value of y? Negative 1, right? Negative 1, right? Okay. Now, are we done? No, right? Now what do you have to do? Plug in y equals negative 1 to either equation, right? Now, which equation is easier to work with?
A.
A, right? Yeah, because the coefficients are smaller, right? Okay, so what do you get? X plus 4 times negative 1 equals negative 1. So what is this? X minus 4 is negative 1. So by adding 4, x is equal to 3, right? Okay, so what's the answer? 3 comma negative 1. Okay, ordered pair. Don't forget to express your answer like that, ordered pair. Okay, now here you can plug in negative 1 into B and still you'll get the same answer. Okay, and same thing for the previous problem. You can plug in negative 6 into A and you will still get the same answer for X, but there will be an easier equation to work with. Any questions on this substitution method? So it's pretty simple, right? Now, here is the third method, elimination. Now, for me personally, I prefer this elimination method better than the substitution method because here's the scheme. So step number 1, instead of isolating x or y, here we now look at x coefficients and y coefficients of both equations and see if they are opposites. Okay, now what does opposite mean? So for example, 2 and negative 2. They're opposites, right? Okay, so basically, remember, what does opposite represent? They have the same absolute value, but they only differ by a sign, right? Okay, now 2 and 1/2, they're not opposites, right? They're reciprocals, right? Okay, they're not opposites. Okay, so not that, but something like this. So check x coefficients are opposites or y coefficients are opposites. If that's the case, go to step number 2. Now, what if that's not the case? If that's not the case, make them opposites. Oh, okay. How do you make them opposites? Multiply one or both equations by small whole numbers. Okay. Now, here, what you might have to do is, you may have to multiply one equation by a number and another equation by a different number. Okay, so that number doesn't have to be the same. In fact, it shouldn't be the same. Okay, so let me write a note here. You may have to multiply one equation by a number, okay, and then by a number, and then multiply the other one by a different number. okay, until you have the opposites. Okay, so again, until you get the opposite coefficients. For X or Y, basically, okay? Again, I had to translate all the math in English, so that's why this looks terrible, but it's not that bad once you actually do the problems, okay? Yeah, see, that's why math is a whole lot better than English, although some people may disagree, especially like English faculties, but whatever. So now, multiplying one or both equations by numbers or a number means multiply each term, okay, of the equations by that number. Okay, so now once you achieve the opposite coefficients for x or x or y, step number 2, you add both equations. Okay, and after you apply step number 2, you will be able to eliminate x or y. Okay, so after step number 2, x or y is gone. And you're down to just one variable, which means what? Step number 3, solve for that remaining variable, and then step number 4, plug in that number into whichever is the easier equation. Okay, and again, this elimination method may look trickier than substitution methods, but it's actually way better. So let's look at the problems. Solve by the elimination method. And here is part A. 3x minus y equals 7, and 2x plus y equals 3. Okay, so now here, again, we are not isolating x or y, but what are we looking at? We are looking at x or y coefficients, right? Okay, like x coefficients or y coefficients, right? And see whether they are what? Opposites. Now, here, what are the x coefficients? 3 and 2, right? Okay, so the x coefficients are 3 and 2, and are they opposites? No. Now, what are the y coefficients? -1 and 1, right? Are they opposites? Yes, right? Okay, so here, the y coefficients are -1 and 1, okay, which are opposites, right? Okay, so what does that mean? Step number 1 is already what? Satisfied, right? Okay, so we don't have to worry about this case, right? Because we already got the opposite coefficients. So now what do? Add 2 equations. So what does that mean? Add A and B. Okay, so now here will be this big addition sign outside. Okay, and then you add vertically. Okay, now what happens when you add vertically? Okay, like this. 3x plus 2x, so that's 5x, right? Okay, and now what happens to y? -y plus y, so they cancel, right? Okay, so just 5x plus 0, right? N is equal to what? 10, right? You see that? Okay, so 5x plus 0 equals 10, right? Which means what? 5x is equal to 10, so x is equal to what? 2, right? Okay, And now we are not done, because now we have to do what? Plug in x equals 2 to either equation, right? Now, which equation is the easier one? It doesn't really matter here, but
B.
B, okay? So what do you get? 2 times 2 plus y is equal to 3. So what is this? 4 plus y is equal to 3. So by subtracting 4, y is equal to -1, right? Okay, so what's the answer? The answer is 2 comma -1, the ordered pair. Okay, and again, you can plug in x equals 2 to a, and still you get the same answer. Now, part B, 6x plus 7y minus 4 is equal to 0. And 5x plus 8y plus 1 is equal to 0. Okay, so now, unlike the previous several problems, what is the biggest difference between this problem and the previous 3 or 4 or whatever?
They have an extra term.
Right? So we have 0 on the right-hand side, and then we have some extra terms on the left-hand side, right? Yes. Now, are we in trouble? Oh, not really. Okay, so don't be bothered by that extra term, because all you have to focus on is what? X and Y coefficients, right? Now, here, what are the X coefficients? 6 and 5, right? Are they opposites? What are the Y coefficients? 7 and 8, right? Are they opposites? Still no. Okay, so now what do you have to do? Okay, so now going back to this step here. So now our answer to step number 1 is what? It's no, right? So now what does that mean? We have to multiply one or both equations by some numbers or number until you have opposite coefficients. Now, how do you multiply A and or B? By which number or numbers? So how can you achieve opposite coefficients for X or Y? Okay, so again, your goal is to get the opposite coefficients. So what is one option? So there can be multiple options here.
30 and -30.
Okay.
For the
so,
X.
Okay, so multiply the top equation by what?
5 or -5.
Okay, it doesn't matter, but so 5 you said? And what about the bottom?
Times 6. Or
Times
-6.
-6?
Yeah, -6.
-6, okay. Now I cannot deny your opinion, so you have to choose the right numbers, okay. Okay, so A times 5 and B times -6. Now will this do it? Let's see. So now remember, when you multiply an equation by a number, you are multiplying the number to each term. So what does that mean? If you chose to multiply 5 to A, you are doing times 5 times 5 times 5 like this, including the ones on the right-hand side. Okay, and if you chose to multiply -6 to B, you are doing times -6 times -6 times -6 times -6. Because there are 4 numbers here, right? Okay, 1, 2, 3, 4. 1, 2, 3, 4. Okay, so what do you get? 30x plus 35y minus 20 is equal to 0, right? Okay, and then multiply -6, so that's -30x minus 48y, and then minus 6 equals 0. Okay, now let me tell you, for the solving any systems, there can be lots of algebra mistakes. So please be very careful. If you mess up with the negative sign, it will cause like a flash flood warning. Okay, yeah, it will cause lots of flooding. So be careful. Okay, so now, do we have opposite coefficients? Woohoo, yes we do. Okay, so now what do we do? Add vertically, okay. So that means here's this big addition sign here. So what happens? X terms cancel, right? And what is the combination of the y terms? -13y, right? And then -20 plus -6, so that means -26, right? Equals 0. Okay, so now, where do you go from here? So add 26. So -13y equals 26, and then divide by -13. So what's the value of y? -2? Is that right? Okay. So now, plug in y equals -2 into either equation, right? Now here, do you see that we have more choices compared to the previous few problems? We have what? Old a and b, and then we have new a and b, right? Which we got after we multiply 5 and -6. So which equation is the easiest to work with? Old a, old b, or new a, or new b? So apparently old A or old B is easier than the new ones, right? Because the numbers are a whole lot smaller. Okay, so let's see, which one is easier? Maybe old A? I don't know, you can choose B, okay? Okay, so what do you get? Old A. So 6x plus 7 times -2 minus 4 is equal to 0. And what is this? 6x minus 14 minus 4 equals 0. So 6x minus 18 is equal to 0. Okay, so 6x is equal to 18. So x is equal to 3, right? Okay, and if you choose to plug in -2 to y in old b, you will get the same answer. So what's the answer? 3 comma -2, right? Okay, so that's B, and then go to C. Go to C. Okay, so here we have 3x minus 5y equals 0, and 9x minus 15y is equal to 0 as well. Okay, so now here, what are the x coefficients? Are they opposites? No. Are y coefficients opposites? No. So how can you manipulate or change each equation so that we have opposite coefficients?
Are you able to only multiply one equation, or do you have to multiply both?
Yeah, so you can just multiply one equation by a number and just keep the other one the same.
Multiply the top equation by -3.
Okay, and then what about B?
Leave it the same.
Okay, so leave B. So what happens? We have to multiply -3 to each term in A. So times -3 times -3 times -3 here. Okay, so what do we have? -9x plus 15y is equal to 0. And then 9x minus 15y equals 0, right? Okay, so now here, do we have any opposite coefficients? Oh yeah, we have a lot, right? Okay, so now when you add vertically, like that, what happens? What is the left-hand side? That, right? Okay, and the right-hand side, 0. Oh, so we have 0 equals 0. What does that mean? Is the answer 0, 0? Yes and no, and you'll see why. Okay, so now here we have an issue because all of the variable is gone. Okay, now is 0 equals 0 true statement or false statement? That's a true statement, right? Okay, so this one is a true statement. If you get a true statement at some point of your work, the answer is infinitely many solutions. Okay, now notice that I did not say all real numbers as the answer, and there's a reason. Now, although this is right, this infinitely many solutions, there is a way that MyLabs Plus wants you to express in this case. Okay, so here is the MLP way, which is kind of annoying, but it makes sense. Now, what you have to do is, first, you have to choose an equation. Choose an equation and isolate x. Okay. Now, what I don't quite remember, although I'm pretty sure that is the case, is you may have to isolate y instead. But it's the same. Okay, it's quite similar. Now, isolate x. And then, so now from here, which equation do you want to choose and isolate x? Which one is easier? The A, right? Yeah, because the numbers are smaller, right? Okay, so choose A. So how do you isolate x? You add 5y, right? Okay, so you get 3x is equal to 5y. Okay, and then you divide by 3. So x is equal to 5 over 3y, right? Okay, so first we chose an equation and we have isolated x. Now, what do you have to do? So the answer is that. Okay, now this is kind of confusing. Okay, this is kind of confusing. So let me explain what this expression even means. Okay, so now we have seen this curly bracket notation before, and it means the set, right? Okay, and then you go from left to right. So it's the set of x comma y, the ordered pair, remember, and then this vertical bar means such that. So it's the set of x comma y such that 5/3 y comma y. Okay, and here y is a real number. Okay, now why does this mean the answer is infinitely many solutions? Because our point or the ordered pair representation is 5/3 y comma y. And y is just arbitrary number, right? So what does this even mean? Can y be equal to 0? Yeah, because y is any number, right? So what happens when y is equal to 0? You have 0 comma 0, right? Which is a point, right? Can y be equal to 1? Yeah. What happens when y is equal to 1? You have 5/3 comma 1, right? What happens when y is equal to -1? You have -5/3 comma -1, right? Okay, so how many points do you get? A lot, right? Because there are just trillions of and countless options for y, right? So there will be countless many points for 5/3 y comma y. Okay, now why is this not the same thing as all real numbers? Because here we have isolated x, but if we isolate y instead, okay, you can verify this, but you will get y is equal to 3/5x. And what's the graph of that? That's a line, right? That passes through the origin, right? Now, this equation means A and B will produce the same graph, which is this line, okay? And what's the solution? Every point that lies on this line, which is what? Just a lot of them, right? Infinitely many points. So in particular, is this the solution? Whatever that point is. No, because it's not on the line. Okay, so that's why this is not the same thing as all real numbers. But still, the answer is infinitely many solutions. Okay, so now, what time is it? Oh, it's 12:04. Now, let's just do this problem, and then we'll do the word problem tomorrow. Okay, so this one is actually short. So, we have 7x plus 3y equals 9, and -14x minus 6y equals -10, okay? So once again, we don't have any opposite coefficients, right? Okay, so how do we change each equation? So multiply a by what? 2? And what about b? We leave it, right? Okay, so that means times 2 times 2 times 2, like that. So what do you get? 14x plus 6y equals 18. And then -14x minus 6y equals -10, right? Okay, and now what are the opposite coefficients? X and y, right? So when you add vertically, what do you get? All of them cancel, right? On the left-hand side. So you have 0. And what is the right-hand side? Also 0? No, it's 8, right? Okay, so now we got 0 equals 8. And is this true or false? False, right? So, which is the opposite case of the previous problem. Okay, now, in the previous problem, whenever we got a true statement, the answer was infinitely many solutions. So what's the opposite of infinitely many? None, right? Okay, none. So what's the answer? No solution. Okay, so it was super short, as you can see. Okay, so the tricky thing here is on part C. Okay, where you get infinitely many solutions, but the standard ones are when you get a distinct or just one solution, which was on A and B. Okay, so tomorrow we will do this word problem, which is just super easy actually. And then we will look at the systems of 3 equations, which means we insert one more letter Z, okay, which sounds terrible, and it's kind of tedious, but it's not too bad. Okay, and then we will go to 5.5. So let's see. I think last night I have posted the 3rd extra credit homework, and that will be due this Thursday, either before or after the test. It doesn't really matter. And then, yeah, remember the exam 3 is this Thursday, and then all of the homework that pertain to the exam 3 will be due tomorrow night. Okay, so that's it for today.